Hi everybody and welcome back to the Siemens electrical product videos. So my name's Chris Ward, I'm one of the product managers for Siemens electrical products, and in this demonstration I wanted to show you the ET200SP motor starter configurator. So for those of you who want to know more about the ET200SP motor starters, please refer back to one of my previous videos which explains where you should use one and the benefits and features. So the ET200SP motor starters are integrated into a distributed I/O system, and what I wanted to show you today is how you'd go about selecting one, because one of the main issues that I've found after managing this range is that there's a few common occurrences in the selection process and in the design phase which perhaps people aren't aware of. Now, if you're using the TIA selection tool to design your ET200SP motor starter system, that'll alleviate those problems for you because it prompts you and tells you when you've gone past the system's limitations and restraints. So yeah, let's crack on and let's see what we can get out of the session. For those of you who wish to discuss anything design-wise, or you want to talk about any potential opportunities regarding the ET200SP motor starters, please feel free to get in contact. So now for the fun part, I'm going to show you how to use the tool and where to find it. So if we go into the Google search engine and type in TIA selection tool online, we'll use the online version. There is a desktop version. So this takes you straight through to the TIA selection tool. Once that wheel's finished spinning, go to new device, I/O systems, because we've got distributed I/O, and then at the top here, ET200SP. So once we're in here, it's very important that we fill in all the information in relation to the specific properties. So do we have a standard application or is it fail-safe? That's critical. So if you don't select fail-safe, you won't see the fail-safe options or product portfolio. The environment and the temperature is also critical for this type of application. And also the information in terms of the control cabinet and ATEX. So it's very important to be thorough at this point of the configuration, because that would depict how the configuration tool limits your selections or also guides you down the right course of action for your particular application. So the next stage, once you've done that, is to go into the configuration and start adding in all the hardware and building it up. So for this particular application, what we're going to do is we're going to focus solely on the ET200SP motor starters. So we'll just pick any CPU. So IM interface 155 with Profinet's fine. Insert that module. We'll add in a couple of input and output modules. So click on slot 1. Add in a digital input, insert that module, click on slot 2, add in an output module, doesn't really matter which one, this is just for use of the application. And once we've done that, we can start focusing on the task at hand, which is selecting and designing the ET200SP system with the motor starters. Now, as you can see, we've got 6 warning messages at this point, but they're more towards the automation system and not towards what we're looking at, the motor starters. So if anything goes above 6, we know that there's an issue with the motor starter selection. So let's start by selecting a motor starter and see what happens. So if we go into I/O modules, go to motor starters, there's 2 different options: direct starter, reversing starter. We'll select direct starter. There's various different options from 0.4 amps up to 12 amps, standard and fail-safe. We'll say it's a 12 amp version. Do we want to start a new potential group? Yes, we do, because you need a 3-phase in-feed. And as you can see, when we insert the module now, you can see the pictorial there. That's the in-feed system. So that's your 3 phases going in and that's your 3 phases going out to your motor. So as you can see, there's an error message. So let's go and have a look at that error message. And it talks about conformity. It says EMC conformity between the motor starters. So by a rule, You're supposed to have all your I/O to the left-hand side of your motor starters. You can't sandwich motor starters in with I/O. And then once you've built up all your I/O, you've got to have a space between your last I/O module and the first motor starter. Otherwise, you might get electromagnetic interference, and then that might compromise your motor starter. And we don't want that. So this is prompting us for those types of eventualities. So if we click on the warning and scroll down, you can automatically correct that. And once it's done that, now what you can do is, if we was to say select another module, and insert that module, it hasn't actually added in that module, but what it's done is it's automatically corrected and added in the dummy module, as you can see there. So the dummy module has now been added in, so we're now compliant with EMC guidelines to the IEC regulations. So let's add in another motor starter, direct online, and let's say we've got another 12 amp version, and we're going to forward that group on and insert that module. And as you can see here, when you forward a group on rather than starting a new group, it means that you don't have to add in another three-phase supply, because it spurs off the initial three-phase supply of that group. And the maximum number of motor starters you can have on that group is up to 32 amps. So you are limited to the amount of amperages that you can have on each load group, but you can have multiple load groups going across this rack up to 1 meter in length. So it's fairly flexible in the amount of motor starters which you can add to the distributed I/O system. So what would happen if we exceeded that? So let's find out. So if we add in another motor starter by clicking on slot 6, and we'll go to add another 12 amps, so it'll take us to 36 amps. We'll forward that potential group. It should come up with a warning, and it does. And it tells us there we've gone over the power consumption for that group. So what it's actually doing is it's correcting us as we're going along. So it's telling us there that we can't actually do what we're trying to do because we've exceeded the load group and the system's limitations. But that's why this tool is particularly useful, because if you try to design a system without using this, you might do something which goes beyond the system's limitations. So you might not have known about the dummy module. You might not have known about exceeding the load group of being 32 amps, but if you're using this tool, it's directing you through and guiding you through the process and telling you the limitations as you're going along, so long as you're keeping an eye on these warnings. So let's add in another motor starter. And we'll say we've got a 9 amp motor starter this time. But what we'll do is we'll start a new load group because we know we're exceeding it. And you can also add additional modules in here. You can add a DI module if you want to, or additional fasteners. But for this application, we're going to focus mainly on the system at hand. So we'll insert that module in there. That'll give us a new infeed, a new three-phase supply in, but it's also popped up with an error message there as well. So as you can see here, it says the device contains the motor starter ET200SP, and it's a DOL which requires a fan. So you might not have known, but there are some temperature requirements with these motor starters to achieve the amperage that it says under certain heat conditions. So if you typed in all the information that you're supposed to in the configurator, it'll give you prior warning to ensure that you've selected the device with the correct components. So in this case, you need a fan. So if we click on the warning and then click on auto correction, it'll remove the warning. So we now know that we've got a fully functional system that's going to work, and we know that this system is now safe and operable and within the system restraints, because there's no error messages in terms of our selections on the ET200SP motor starter selections on that distributed I/O system. You can also do that with fail-safe devices as well. So if anybody's using ET200SP motor starters on a distributed I/O system, it's highly recommended that you use this system because it gives you assurance in your selection, but it also gives you guidance around the selections as well, because not everybody's aware of the system restraints. There has been circumstances where people have selected these based off what they deem to be the correct path, but if they're following the automated process through this TIA selection tool, you won't have any issues further down the line. If you install a product beyond its limitations, then there could be problems further down the line, and that's what we're trying to avoid. We're trying to show you these tools to make your life easier and to avoid any problems. So I really hope that you found the video useful. If you have any questions, please feel free to get in contact. Many thanks for watching.